So far we've talked about z-scores, the standard normal distribution model, as well as the normal distribution model, and we've talked about how you can, given a certain range of values, find probabilities, or percentiles even, within a particular range using statistical software or normal probability tables. Now let's put all of this together, use an example based on the heights of male adults. So the heights of male adults between the ages of 20 and 62 in the United States is approximately normal, with a mean mu of 70 inches and a standard deviation of sigma 3.3 inches. We might ask, what is the probability that a random adult male is between 69 inches and 74 inches, or 5 foot 9 inches and 6 foot 2 inches? We will convert these values to z-scores and then find the probabilities using statistical software with a comparison to normal probability tables. So the idea is we want to find lower and upper bounds, z-scores, because we want to find the probability that a random adult male is between, a randomly selected adult male is between 69 and 74 inches. So let's first convert these values into z-scores. Since we know the mean in the population and we know the standard deviation of the population, we know where the lower and upper z-scores are in relation to the mean. So the lower z-score is 0.3 standard deviations below the mean in the population. The upper z-score is 1.21 standard deviations above the mean in the population. So we have a lower z-score of negative 0.30 and an upper z-score of 1.21. So the goal then is to find a probability of a z-score within that range, because we want to find the probability that a randomly selected adult male is between 69 and 74 inches, or equivalently between a z-score of negative 0.3 and a z-score of 1.21. So we can find these probabilities very easily using statistical software with a visualization. So based on these two cutoff values, we can see that we can chunk the standard normal distribution into these three segments, and we can find the probability very easily. The probability of a z-score between negative 0.3 and 1.21 is just given by that middle area, that probability for that area in that middle part of the curve. Okay? We can also use tables, or normal probability tables. So for these tables, we're given the probability below a certain z-score. So each of these values, these cells, give us a probability of a z-score being below a certain cutoff value. So to find the probability of the interval, okay, we want to take the probability of a z-score less than the upper value, subtract out the probability of a z-score less than the lower value, and that'll give us the probability of a z-score within a particular range. So when we use these cells, okay, we find a certain probability that is equivalent to the statistical software. And we conclude that the probability that a randomly selected adult male is between 5 foot 9 inches and 6 foot 2 inches, including those two endpoints, is about 0.505. So about 50%. We'd expect half the time that we're going to have if we randomly selected adult male, they're going to be between those two heights. So that's a pretty big chunk of the population. But keep in mind that using this kind of technique, it requires us to know that the population distribution can be approximated by a normal distribution model, and that we know the population mean, mu, and that we know the standard deviation of the population, sigma. Let's continue with a few other points about working with z-scores. So because it's easiest to use z-scores with some kind of visualization of the standard normal distribution model. So that's why we will typically use statistical software. Sometimes the tables can be a little bit misleading because people focus more on the numbers and finding those probabilities rather than realizing that these probabilities are from a normal distribution model. It's just the area under the curve, because the normal distribution model, and just the, whether it's standardized or not, it gives you the area under a curve. Right? Often normal probability tables give you a probability below a certain cutoff value for a certain z-score, while in general, statistical software tends to give you the probability of a z-score being less than or equal to a cutoff value. We will treat these as roughly approximate, because in all practical applications, in nearly all, it doesn't make much of a substantive effect. So that's an important point. Now the last point when we talk about working with z-scores and the standard normal distribution is something called the normal coverage rule. This is just the empirical rule in a more formal fashion. We're just revisiting the empirical rule. If you recall, the empirical rule said if a distribution of data is roughly mound-shaped and symmetric, then we can make these characterizations that roughly 95% of the observations are within 2 standard deviations of the mean, and 68% of the observations are roughly within 1 standard deviation of the mean. Well, we can also use that characterization with the normal distribution model. So if we know something about the normal distribution model, we know that roughly 68% of the values are going to be between plus or minus 1 standard deviation, 95% are going to be within plus or minus 2 standard deviations of the mean, and 99.7% of those values are going to be within 3 standard deviations of the mean. Equivalently, we can treat these as probabilities. Okay? The point is that most of the values are centered around the mean within a certain standard deviation. And we can express this in terms of the z-scores or in terms of the normal distribution model. So the normal coverage rule applies because the normal distribution model is in fact mound-shaped and symmetric. So this is what the normal coverage rule looks like in terms of plus or minus 1 standard deviation. This is using the standard normal distribution. And you can see that the probability of having a z-score within 1 standard deviation is about 0.68. 68% of the values are within 1 standard deviation of the mean. Right? The normal coverage rule states the probability of having some z-score within 2 standard deviations of the mean is, that probability is 0.95. Equivalently, 95% of the values we'd expect to be between 2 standard deviations, roughly, of the mean. And then for the normal coverage rule with plus or minus 3 standard deviations, we'd expect a randomly selected z-score. There's the probability that's going to be within 3 standard deviations of the mean, either above or below. That probability is very high, 0.997, or roughly 99.7% of values we'd expect to be between 3 standard deviations, either above or below the mean. So several things to know in terms of the standard normal distribution working with z-scores. Right? The standard normal distribution model is simply the normal distribution expressed in terms of z-scores. If we know a variable is roughly normal, and we know the value of the mean and the standard deviation, then we can use z-scores to find probabilities under the standard normal distribution. So we can find particular areas under that curve which are equivalent to probabilities. Often we will use statistical software to find these probabilities, but we can also use tables. And as well, if we can use the normal distribution model, either the standard or the conventional normal distribution model, we can also apply the normal coverage rule to make characterizations about the distribution. And with that, we've concluded our discussion of the normal distribution model, z-scores, and the rest of the topics for this lecture.